Yes, so in this short presentation, I'm going to talk about, as we said, about how to build data pipelines with Drake and how to put your code inside a container to make sure it runs pretty much anywhere. So the main idea behind most data analytics project is to build a data product. And if you build a data product, you can split it up into a sequence of tasks, from getting the data to making plots to fitting a model. And second of all, you want to make sure that the environment that you run your code in can be replicated. So basically, splitting up your project into subtasks makes automation easy, and putting it inside a container makes it reproducible. So Drake is a really cool new R package that takes a lot of the best features from perhaps more mature Python frameworks such as Airflow or Luigi. And the main idea is that you create a sequence of transformations. So how does this look? You basically write a plan, and your plan can be really, really simple, or it can be more complex. And here, this is an example of a simple plan where you read your data, you create a new column, and then use this column to fit a simple model. And the cool thing about Drake is that you can visualize your data pipeline. So not only the outputs of each of these tasks that you can graph, but you can also see what are other objects that we need. So in this example, the iris data set, we need to import some functions and so forth. And another nice feature is if you have a more complex data pipeline, you can monitor the progress. So this keeps on updating while you run your job. So if you created your plan, it's really easy to run it. Basically, you just do make my plan, and then what Drake does, it checks all the dependencies of your project or of your data pipeline and see, do we have everything in place to run this? And if you run this for the first time, there's going to be nothing cached, but if you run it for the second time, everything that you've run before and hasn't changed is going to be loaded from cache instead of ran from scratch. So this can save a lot of time if you have more complex jobs. So that's for Drake. The second bit is about containers. So containers, you can think of them as virtual machines, but kind of different. So a virtual machine is like a pre-packaged, sealed-off mini computer where you cannot tinker with much. But a container, you basically get the building blocks where you can build your own little environment. So the main benefits, as mentioned in the previous talk, you can replicate your environment that you ran your code in. So whatever results you get locally is going to be the same what you get on a server if you run your container. Secondly, it runs on any operating system that has Docker installed. So Windows, macOS, Linux, it doesn't really matter. And what all of this means is that you get a consistency in production. So the errors you're going to encounter in production are going to be exactly the same errors you're going to encounter locally. So it gives a peace of mind when you push things inside production. So how do we create a container? It's one way is to write a Docker file. And working backwards, what you do is you put your script inside the container, which is here run workflow, which contains the Drake plan that I outlined before. And then you look at what are the dependencies of this code. So what are the R packages that we need? And what are the system level dependencies that these packages need to load? And that's it. And once you define your Docker file, you can just build your image by running docker build. And what this does, it builds your image layer by layer. So each layer is basically one line in your Docker file. And what happens is the first time you run this, it might take some time to build up the image. But if you run it for the second time and you only change bits in your script, all the layers that come before are going to be cached. So that means it's going to be real fast on subsequent runs. So once you have your image, you can run your container with Docker run, and you see here 2 flags, D, which means detached mode, so it's going to run in the background, and the flag V basically binds a volume from the host system. So you don't need to put all your data inside a container. Docker can read data from the host system directory. And then you give it a name, and that's it. And once the container spins up, runs your script, it will die after it's finished. But still, you can get your data out of that container. So it's a really easy way to, a reproducible way to run your code. So that's it. I have a blog where I've written a post about Dockerized Shiny app development, which goes into more detail on best practices, and you can also find me on Twitter. Thanks.